introduction. Can you hear me? Yes. Okay. So, as you can see, this is the main problem we're going to discuss today. And I want this talk to be as interactive as possible. So just raise your hands, complain, and help me, because we would love feedback in this project. So, when we see some phrase with some weird mistake, first step could be identifying which are the words or sentences with some sort of problem. Then we could want to classify what is the problem, what is happening wrong. So there is a spelling mistake in writing, there is a capitalization mistake in English, write is correctly written, but not with this meaning. So, and then once we identify there, we can classify it and we can propose which would be the correct words to correct that thing. So I've been working with Python for more or less 10 years. I've used already lots of programming languages from Java to Go, C, blah, blah, blah. I'm Brazilian. I live in London for more or less 2 years now, working for a company called Education First. So what made me move from Rio to London was the possibility of applying technology to education. And this work is part of what I do at the company. So I love Python, I love open source. And this is the company where I work. Who here heard of EF? Well, quite a few people. I had never heard about it when I was headhunted by them. And then I realized they have 40,000 people around the world. So they're basically an education company. They have interchange programs, they teach lots of languages. They have their own schools, they have corporate trainings. There are 500 offices around the world. I'm part of a kind of startup team called CityX, which tries to apply technology to classroom. The work I'm presenting here is not related to my key work, main job there, which is to develop these applications which are used inside the classroom, but it's related. So we develop an authoring platform, teaching things, self-study materials. This is our team, so it's a quite international team. This is our team this year, none other team event we had. And this work I'm presenting here, which is called Writer, was done with Rafa. Rafa is a colleague and friend from work, and we've been trying to build from food to software. This far, software has been more successful than the food, but we are always trying to learn and improve what we do. The objective here is to present to you guys a challenge. And I don't have a solution for this challenge yet, and perhaps you can contribute to present a data set you may not be aware of, introduce some Python scripts, which are not very nice, collect ideas, and build together some tool that can help us dealing with this problem of identifying and correcting English mistakes. So, in EF, we have an online platform where teachers can teach remotely and students can study at their own pace. And one of the challenges is to access the writings of those students. So there are hundreds and hundreds of essays, and sometimes teachers can just go crazy because it's quite boring, depending on the level of the student, to actually go through all those writings and check the same mistake over and over again. So this is an example of writing from one of the students. You can see some capitalization mistakes. So it's very common for I, N to be misspelled, and so on. Capitalization, spelling mistakes. From here is far, to is tall. And even verb tenses, I'm leave, whereas it should be I leave. So there are all sorts of mistakes. Can you imagine yourselves spending hours and hours checking this kind of thing? Well, I couldn't imagine myself, so what we're trying to do is to improve the work of these teachers. Currently, we have hundreds of teachers doing this kind of things manually, without any kind of support. So they use a platform and they go highlighting and trying to explain and suggesting how the students could improve. So the initial challenge Rafa and I had was, cool, so we have a problem, we have some data, let's start coding and implement our own solutions for this. So our aim was to try to reproduce what Microsoft Office, LibreOffice, and all those apps have, highlighting and whenever possible suggesting a correction for some English mistake. So our input would be English texts, and then the output would be positions in the text where there is some kind of mistake, the type of that mistake, is it a capitalization, spelling, is it a verb tense, and eventually a proposal of correction. As we were just starting this as a proof of concept, we were quite fine first just to identify positions in the text of things we thought were wrong. Even though that wouldn't be the ideal, it would already help our teachers. So to do this work, we got a data set from EF. So this data set has 500,000 written essays, over almost 3 million sentences by almost 100,000 students of 16 levels of proficiency of almost 200 nationalities. And the cool thing of this, there are lots of topics from introducing yourself to resume, how to play a game, reviews, letters complaining things. There are people from lots of nationalities, Brazilians, Chinese, Russians, Mexicans, and this data is available to anyone. So as long as you don't want to gain money with it, you can download it. There is this project in partnership with the University of Cambridge where the data was processed. They built an interface where you can filter some of the texts you would be interested, and you can retrieve all this. And the cool thing is, not only we have those essays, but we have the annotations the teachers made. So you can use this information if you want. So these are some of the mistakes that were written: article, agreement, capitalization, combined sentence, missing word, possessive, plural, singular. This information is available, and let me see the link here. Where's the link? Here. So these slides will be available, but if you go to here, you will be able to access this data and download it. And if you're interested in playing with scikit-learn or TensorFlows or whatever amazing technology or data processing or machine learning technique you guys enjoy, you can use this data for non-commercial use. So, any questions this far? Okay. So, this data set is distributed, it has lots of information, and it's interesting to see the most common mistakes. This diagram is not very clear, but you can see here the level of the students and the number of errors they had, the average. So most of the students start having lots of articles, capitalization, spelling errors, and so on. And with time, they tend to be solved. Some problems will stay during the whole life of the person because they were not addressed. But usually, more advanced learners make less mistakes. And the 3 most common errors we found were spelling, capitalization, and article. And that was what we initially tried to sort. So Rafa and I, we decided, why don't we try to sort those things? We had a very short time, like 3 hours, and we decided, let's see what we can do with Python to try to solve this. This is just a screenshot of how the data normally looks like. It's a horrible XML, which has lots of parsing issues, but we did release in our REPL, which I will be showing how to parse it and have a nice JSON, avoiding some of the issues so you can process things easier. So most of the project scripts we wrote together followed the Go Horse methodology. Who here heard of the Go Horse methodology? Okay, so imagine agile methodology. Go Horse is just the opposite. So you don't use tests, you simply write it until it works, and eventually it will work, and then it will stop working. So our idea was just, let's have this problem, let's try to sort it out somehow. It's not a production code, but we can have some fun with it. So that's how it started. So this project lacks automated tests, proper code design, and a documentation. It's still, so if you want to know more about this amazing methodology, you can see here about Go Horse. It's really, really cool. So what did our scripts do initially? We had to try to improve the data we had available, so fix and parse the XML files. Then we converted them into good-looking JSON files. We defined some heuristics of what could make sense to identify spelling mistakes, or capitalization, or article, and we checked how efficient our algorithm was. So the code is all available under Apache version 2 license in GitHub, and you can download it and check it afterwards. And our initial purpose was to deal with the spelling, capitalization, and article issues. In order to check the efficiency, we used measurements that are usually applied to data analysis. So we basically used precision and recall. So I always like to use the platypus example when I think about precision and recall. So who here is no platypus? They are my favorite animal. So in this slide, hopefully you can see we have 3 platypus samples, 2 ducks, and 2 beavers, which would love to be platypus as well, but they are not. So if we had to classify, our problem is, given these images, just tell me which are platypus. We see the green ones, framed ones, are the platypus, and the other ones are the ones not platypus. And then, let's say we had an algorithm which extracted the features from these images and gave us, okay, so I think this script thinks these 3 images are platypus. But as you can see, 2 of them are, but it got one wrong. So one way of measuring how good this algorithm is checking the precision, which would be, given all the things the algorithm said, these are platypus, check how many of them are actual platypus. So it just analyzes what the algorithm suggested to be true. And in this case, the precision would be 66%. And we also have recall. Recall takes into account, given all our data, how many platypus do we really have, and how many did your algorithm identify. So in this case, we had originally 4 platypus, our algorithm got 2, so the recall is 2 out of 4. As you can imagine, these 2 measurements have issues. So in the precision, if we only had an algorithm which only identified this image, we would have 1 out of 1. So our precision would be 100%. It's a great algorithm, isn't it? But we are leaving 3 behind. Whereas in the recall, if we had a very naive algorithm which selected all the images, we would still be getting 100% recall, because we would get all of them. The algorithm would say we have 8 platypus, and would get out of the 4 that exist, the 4 that are real. But that wouldn't be a good algorithm either. So usually, a way of trying to balance precision and recall to some number that would be cool and would be more meaningful is the F-score, which is applied by this formula. And so our idea was to compare our results to the real annotations from the teachers and be able to extract what was the precision of our algorithms, what was the recall, and check if we were going on the right way or not. So, spelling. These were some of the heuristics we used. We removed Unicode, we transformed accents, we removed punctuation, we checked if that word was available in some dictionary of the system. And then, if those things were not right, that word was probably misspelled. We validated this technique in 85,000 essays, only a sample of what we had, and we got 71 precision and 65 recall, which is not bad. So any of you could have done a spell checker using Python and go horse methodology in 1 hour, which is, it's quite fascinating. So these were the results we had for spelling checking. These were some analysis based on nationality and all. Capitalization, we also had a few basic heuristics. Is it a person name? Is it a day of a week? Is it a month? Is it a language, country, names? So we had some lists which we collected online with this kind of information. And again, we got quite successful results. 57 precision, 55 recall. So that's based on level. And then articles, we were just checking A and AN in front of vocals and consonants. And again, we had a quite surprising good result with the sample we were using. So we were very, very happy with our few hours of work and good result. And then I went to present in PyConUK. So in Slovakia, Bratislava, this year, I thought, wow, so we had so little work and we got so interesting results. Let's show this up. And then I received lots of feedback. So why are you reinventing the wheel? And how does it compare to LibreOffice or Python or many other applications, commercial applications? Why don't you try machine learning? Why don't you build a nicer interface? By the time it was just a command line. And then we thought, okay, you are right. So what could we do? So since March, we didn't spend a lot of time, but we tried to do a few things. So first, we created a sample paragraph with a few English mistakes. Then we listed all the solutions we would like to have initial test and evaluation. We analyzed how the solutions worked or not for our paragraph. We filtered what we considered the best solutions, and then we did a quantitative analysis. So this was the sample. The book is on a table. So here you have article, here you have spelling, there you have capital, and it came to Europe. Although 2 exists, it's not in the correct place, so this would be a spelling, capitalization again, Monday capitalization. And then Julia has lots of friend, so lots of friend, this is incorrect. She's happy yesterday, so the verb tense is incorrect. And then we thought this had a horrible English overall structure, and it could help us identify some of the algorithms and programs that exist, and we could compare to whatever we had. So this was a list we made with open source and private projects we got online. And we initially tested this phrase with all of them. You can see the detailed thing in this Google Doc. But overall, we wanted to select half-half open source and proprietary. And we note some proprietary solutions were probably using the open source one. So the ones that exactly gave the same result, we excluded, and we tried to keep it as short as possible. So PyConUK, who knows PyConUK? It's an awesome Python project that exposes handspell and aspell, which are the spell checkers used for lots and lots of projects, including LibreOffice. And it's in Python. You can use it very nice. If you want to add new words to your own dictionary, you can. And it supports a few languages. So we kept it. Language 2 is a project developed in Java, and it's based on rules. So we have lots of rules, and you try to apply those using regex or so on. Ginger, White Smoke, Grammarly, and eAngel are all proprietary applications, which gave us interesting results in this first analysis. And Wikipedia Topi is another open source thing that's used by Wikipedia to help people avoid mistakes. And Topi is the Python project which allows you to use it, to use the rules they use. An interesting thing is, both this and language 2 are rule-based, so they're not using machine learning. And we don't know exactly what is going inside of the proprietary solutions. But it's nice to analyze the results. So for that specific phrase I showed to you, we got some candidates we would like to keep testing. As you can see, language 2 and Topi. Topi didn't do very well for this guy. The language 2 found 7 mistakes. There were 11 mistakes, and we had one proprietary solution which found the 11 mistakes. And now, the impressive reality. Yesterday, Daniele told us that someone asked him what was the amazing software we were using for speech-to-text in the auditorium. And he said it's a technology developed millions of years ago that's human-based. So there is someone actually listening and typing. And the best corrector we had online was human-based as well. So far away from the others, it got an impressive result. So once we had this analysis, we saw, well, to be proprietary or open source doesn't matter so much. So let's try to get some more numbers, because there was a too small sample. So we got 500 essays just so we could run things faster, and we run for all the applications. One important detail there is, I'm not sure how legal it is what we did. So in some cases, we made scripts which automated using those services. So Grammarly uses WebSockets, a very weird implementation. Most of the services use an HTTP API. For the open source ones, we had wrappers for Python, which made things very easy. But all in all, it was quite of a work to get the things running. And we managed to make a script that exposes the interface of the services. You can use even my cookie if you want. And you can get, in the same format, the responses from them. So in theory, you would be able to write your own text and compare how well each of those solutions do. And this is all in our repo. So when we run for a sample of around 500 essays, we calculated the precision and recall and F-score for all the solutions, and we also computed the time. And one fascinating thing is, if we got only the 2 open source solutions, the 3 actually, we would get very, very high results. So if we had just a Python application which merges this open source interaction, we would probably be outstanding the proprietary applications just using open source. Of course, this is an initial analysis. Lots of complex English mistakes are probably not seen by those. Here, there must be lots of spelling mistakes and simple mistakes, which these tools may fix better. But it is interesting because I would expect the proprietary applications to be using the open source ones, which allow to be used for commercial use. But that doesn't seem the reality. And there are algorithms which run in less than a minute. And of course, those that we had to process requests remotely via WebSockets or HTTP took much longer. So we built this interface. Let's see if I get this. So very quickly.
Yeah, it's two.
Okay, so if you type, oh my god, writer.ctx.f.com. So we built this graphical interface. We added two categories. The mistakes we worked on more time, articles, capitalization, and spelling, or all the errors. And then you can select an algorithm you would be interested in. So let's say we want to just articles. We want to use one of the proprietary solutions. For legal purposes, we decided not to say explicitly here the name of the solution. But as you are developers, if you open Google Inspect, you can see the request, and you can see what is the actual product being used. We allow you to generate some texts. These are from our database, so you can see. And then you can check. And hopefully, it will work. Oh my god, it didn't. Let's try again. So this one, let's say this, writer, and check. Yes, guys. Live demos are always like this. I swear it was working before. Let's try one last time. But you can use it, so just after here I will check what is going wrong. So you can type your own thing here. Hello, this is a mistake. And check it. And then writer would check for you and show here very nicely all the mistakes. But I know you trust me, and this will be back soon. So some ideas we had is to check the strengths and problems of each of the approaches, both open source and proprietary, extend open source projects, using fun machine learning things, implement what is not available in them, which mistakes are not caught, and improve the interface. Ideas, I'm all open for ideas and suggestions, so please give us feedback. And this is my Twitter, this is the email of our team. As most people here, we are recruiting, we are looking for back-end Python engineers, if anyone is interested. And if you just want to contribute with this project, you're more than welcome. So that's it. How much time do we have for questions?
So I think, because it's just a break now, I think we've got time for a couple of questions or suggestions. If
have you considered trying a combination of methods? So if one method is good at one area of error detection and another is better at a different area, do they work as an ensemble?
We thought we didn't do, and that's a great idea, so I will add here. Oh, your user doesn't have permissions. But yes, I will send to myself by Slack. So, combination of methods. It totally makes sense. We need to try.
What were the problems you were having with XML? Was it not valid?
Yes, it was
This
invalid.
is data set coming from Cambridge, so have you reported it as a bug?
Yes, it's a bit tricky because it came originally from our database, and there was one developer in Cambridge who worked on it, and he went away, and we did report to them, and we will be sorting it out. So they were with lack of resources in this specific team,
Okay.
and we will probably just send to them the fixed XML. I need to follow up on this as well.
And you've not looked at any natural language libraries?
We didn't use any
Why?
time. So until now, we didn't have the
If you can't
chance.
feed your horse, it's going to die.
I know, but I have the hope more people will help feeding the horse. And but I totally agree. So
You're feeding it with rocks at the moment.
wow, that's true. We're horse. So we will deal with natural language processing, and I promise, as soon as we have results, we will share again. But it does make sense. And anyone can try, and you guys can even compare with the other ones. And the interface will soon be better. So we really would appreciate support from all sorts. More questions?
Oh, if there's any more questions, then we'll wrap up there. And thanks, Tatiana, for a really nice talk.